Now what we're covering today is surface area. We're continuing on with surface area. Yesterday we talked about prisms, so three-dimensional shapes that have two bases that are the same. And we also noticed that rectangular prisms, we could have different bases depending on how we wanted to look at it. And we have the lateral faces. And then we finished off with cones. They're not cones, cylinders. Cylinders are just a prism with circular bases. Now what we're going to be talking about today is three-dimensional shapes that do not have two bases, so we can't consider them prisms. Now the first type we have are pyramids. Pyramids. And we can have a regular pyramid and not an irregular, but just not a regular pyramid, because a regular pyramid has a regular polygonal base. So the base of the pyramid has all congruent sides and all congruent angles, and if that's the case, we call it regular. Now there are some different parts of a pyramid. We have the base, the bottom of it, which is really defining what the pyramid is. And most of the time when we talk about pyramids, we think of a square or rectangular pyramid, because the ones that built in Egypt are considered square or rectangular pyramids because the base is a square. It has a height, which is a straight line going from the vertex straight down to the base and makes a right angle. We also have lateral faces, which are the sides, and we also have something called a slant height. A slant height is pretty much along those faces if we were to go straight up the side of it. If you go straight up the side of the pyramid and can make a line from the vertex to the base edge, and it'll make a right angle, that would be the slant height. Because it's the height, but it is slanted, so we call it the slant height, which would be the height for each one of those sides. So we have it right here. Now the overall formula, or kind of formulas that we have for finding the areas of these pyramids, is really going to be the area of the base plus the area of the sides. And if we look at this here, and we look at this shape, and we can delve into this a little bit more than we did yesterday of how we actually get this. Well, this here is a square pyramid because we have a square base. So if I break this apart, we have the base, and then I would have 1, 2, 3, 4 triangles. Those 4 triangles are making up the lateral faces. And if I want to find the surface area, really we need to know the area of each one of these shapes and add them all together. Now the area of the base for a rectangle is just going to be base times height. Base times height, length times width. And for a triangle, it's 1/2 the base times the height. And that'd be the same for all of these here. Now, will the lateral faces for a pyramid always be triangles? Because for a pyramid, it's always the base, whatever it is always reaching up to a point, yes? So a cone, yes. And our base for a cone would be a circle. So that's why we differentiate between a pyramid and a cone, because the base is a circle. It's understood. Now for pyramids, the base could be square, they could be rectangular, they could be octagonal. We can have an octagonal base, and we can have many different sides. But it's always going to be going to a point, so the most sides of any lateral face that we can have is 3. So it's going to be stuck at a triangle, unless it is a cone, which would be a triangle, but one of the sides would be curved. And we'll get into how that works in a little bit. When we look at this here, we have, well, 1, 2, 3, 4 this time. And we're really adding these together to find the area of those lateral faces, yes? Well, they all have the 1/2 in common. So using properties of factoring, I can factor that 1/2 out because it's the same. The height is going to be the same, which really just leaves us with all of our bases being added together. And as we saw yesterday, this here is really just the perimeter. So that's where we get, especially in that formula where it says 1/2 base times height, or 1/2 of P times L. P is the perimeter. It's really adding all those together. So we can take all of those areas and put them into 1. All those lengths and put them into 1. Now, probably also wondering, well, it says L, not H. Yes? Well, the actual height of each side is not going to be a straight length. It's a slant. Because the slant height is actually going to be the height of each one of the faces. So we don't call it H. Scroll down. We really just call it L for our slant height, because it's the height of each one of those sides. Because it's going to work out that the slant height is actually going to be longer than the actual height of the triangle, the height of the pyramid, not triangle. Because if you go down a slope, you're actually going farther than if you went straight down. But we have this here. So the area of the base for us here is just base times height, because it is a square. So we can have different sizes or different shapes. So we'll have to use the area of the base accordingly. But the slant height, not slant height, the lateral faces is really going to stick to this 1/2 perimeter times the lateral height, the slant height. So we'll look at a few of these here using this kind of formulas. So for our surface area here, we're going to need the area of the base, and with most of these pyramids, we only have one base, because it's just the bottom. And then we need to find the area of the lateral faces. Now this base is a what? Hexagonal. So it has, hex means what? 6, so it has 6 sides, yes? So the area for our base is going to be 1/2 the apothem times the side length times the number of sides. Well, we just said it has 6 sides. Yes? What is the side length of each one? 10. We'll use the 14 in a little bit, because since the 14 is referencing this line here, it's talking about the slant height. So we'll use it to find the areas of the lateral faces. So since right now we're just talking about the bottom, the base, we're going to use the 10 for the side length. And the last thing we need is the apothem, which would be pi squared of 3, because that's really the only unit we haven't used yet. Now again, at this point here, we can type all of this into the calculator to get our answer. $259.808. So 259.808. So that right there is the first part of our surface area, because we found the base. We found out how much space the base takes up. Now we need to find the lateral faces. Now it said the area formula for our lateral bases is 1/2 LP. 1/2. Well, the L is our slant height, which is 14, like we pointed out a minute ago. And the P is the perimeter. How much is going to go all the way around? Now we can do 10 times 6, because we know it's regular, so all the base lengths are going to be the same. I think this is 420. Is that what y'all got? So 14 times 10 times 6 times 1/2. Yep. And that would give us the area of all the faces. So if I want to know the overall surface area, we just have to combine these two, which would give us 679.808, and it would be feet squared. Any questions on this here? Any questions on anything we've done thus far? We good with this here? We ready for the next one? All right, we have a regular hexagonal pyramid. So again, we have 6 sides, hexagon. So the first thing we can find really is the area of the base, which would be 1/2 the apothem times the side length times the number of sides. So what's our apothem? Four square root of 3. Our side length would be? Yes, sir.
I was just going to say, could you also find the area of that triangle and then multiply it by 6?
Yes. Let's do that. We'll do that on this one, and I'll show you kind of how that works out. All right? And then 6. What is it? 96 square root 3. Any questions on how we found the area of the base? We good with area of the base? Okay. Now let's find the lateral faces. Now, we're going to look at this a little bit differently because, as Reed said, because we can find one of the areas of the triangles, and since they're all going to be the same, we can multiply it by 6. Now, the area formula for a triangle is 1/2 the base, which is 8, times the height. Now, the height for us is going to be our slant height because we're going up along that triangle, which would be 20. And if we find one of these here, which would be 80. So each one of these has a surface area or an area of 80 feet. And if I want to know all of them, we can take that 80 and multiply it by 6 for an 80. So what we did is we took this here, the area of the triangle, 1/2, 8 times 20, and then multiplied it by 6 because that's how many we had, yes? Now, I'm going to rewrite these numbers just a little bit. Y'all don't have to write this down. I'm going to move the height over and have 8 times 6. Because this here is 1/2 our height, yes? 8 was our number of side, or 8 was our side length, and 6 was the number of sides, yes? Well, this here, because since our side length is 8, and if we add them all together, we get the perimeter, yes? Well, adding them all and multiplying it by how many we have is the same thing, yes? So it's the exact same thing. We get to the exact same place. So does that make sense how those two line up to be the same? So it works either way. If doing it this way in red makes sense, do it that way. Do it that way. There's nothing wrong with doing it that way. If you like the way we did on the first one where we found the perimeter and used that way. because we get to the same answer. Pick which way works best for you. And last but not least, we need to add these together. 646 what? 0.27. And this would be feet squared. Feet squared. I'll take either form, because if you want to put it in decimal form, put it in decimal form. Because 480 plus 96 squared to 3 feet squared is still the same thing. We just didn't convert the square root of 3 into a decimal. Any questions on this here? Any questions for anything we've done so far? All right. Last one we'll look at before we look at cones is this one here. I think we have this one. Yep. We have a pentagonal base. So this base does not have 6 sides. It has 5. Pent is 5, which means we have 5 triangles, lateral faces. So overall surface area. So we can find the area of the base first. Area is going to equal 1/2 the apothem times the side length times the number of sides. Now it told us our apothem for this here is 5.5. Our side length is, and the number of sides is 5, because we have so we all agree with 110? 4. Any questions on this here so far? So that gave us the area of the base. Now we need the lateral areas. So that's going to be 1/2 of the slant height, which is actually, if we have this here, is 7.3 meters. And then we would have the perimeter, or we can say the base length times the number of sides. Either one would work. So the base length would be 8, and the number of sides is 5. It's nice it worked out evenly. Yep. Any questions on any of this here so far? Sir. I'm going to give you the slants. I will give you all of those. So on the test and on the homework assignments, I will give you the apothem. I will give you the slant height. I'm not going to make y'all find those. If we had more time than pretty much next Tuesday that we're taking the test, then we'll delve into a little bit more of actually how to find those. And I'll delve into it here in a second of actually how we find the slant height. $256, and it would be meters squared. Okay. I'm going to pause. So any other questions on these pyramids before we look at what's next? Cones. Cone is the other shape that we're going to look at today. Now a cone is very similar to a pyramid in that we have a base, and this time here it is a circle. And the base of a cone is always going to be a circle. So our base is always going to be using pi r squared. Now, the one that always comes kind of interesting is the lateral faces is pi r L, where L is the slant height and R is the radius. And this comes really from our overall shape. Now, this isn't in your note sheet, but if we look at a cone, poorly drawn cone, this distance here is our kind of overall slant height. Because what I've done is I've taken the cone, if we cut the bottom out and flatten it out, we get this kind of shape where it arcs out. If y'all have ever taken one of those little cups you can get for the water fountain and torn it apart, it looks like this here. It has that cone shape. So the overall height is L. Now, you're probably wondering how we get this, and this is 2 pi r. Sorry. Make sure I get this small. This is our slant height from here to here. Now, you're probably wondering how they got 2 pi r L for the overall area of this here. Now, what they did is kind of, this is ingenious, is they took this here and cut it up into little slivers. And what they did is they realigned those slivers. Like this here. And put them next to each other. Now, they're obviously all going to be at the same level, up and down. Now, this here is very close to what kind of shape? It's a rectangle. Where the overall height is L. Now, these here are this here broken up. Now, if you notice, we've been alternating them, or I alternated one up, one down. So I really took that overall length and cut it in half, yes? So if I cut 2 pi r in half, well, the 2 becomes, which makes this side length here pi r. Well, the area for a rectangle is length times, so 2 pi r times L gives us pi RL. That's actually how they got the area for the lateral faces, which is actually kind of ingenious. I mean, actually figuring out a way to find this, especially since this here has a curved edge. So really, for any cone, the surface area is equal to pi r squared plus pi r L. So just like with cylinders, we do have an exact formula for this here. Yes. Now, we can use this formula, pi r squared plus pi rl, to find the area, the surface area of the cone. Now, what's our radius going to be? So in both of the r's, we're going to fill in 6. And L is our slant height, so would we fill in, what would we fill in for it? 10. And at this part here, we would just type this into the calculator to get our answer. We're going to do pi times 6 squared plus 6 times 10 times pi, which would actually give us 96 pi. Any questions on any of this here? Any questions on anything we've done thus far? So when we look at this here, the two things we need are the radius and the slant height. Now our radius for this cone would be 5, and the slant height is 13. So the surface area would be 90 pi. Any other questions about finding the surface area of these cones? Yes. Do we feel comfortable with finding the surface area of a cone? Because really, once we use this formula here, we kind of are able to get the area from it. It's kind of nice. So we'll skip on to the last thing that we're talking about here. Now, the last thing we're going to talk about is similar three-dimensional shapes, similar pyramids, similar cones. Similar pyramids and similar cones. Now, what we talked about yesterday and how we solved those yesterday are going to be the exact same as this here, because similar shapes are always going to have similar scale factors. So we have two pyramids here, and we want to find the surface area of the bigger one. Well, we can set up our proportion. The surface area of 1 over 156, the one we want to find, over the one we know. Now, this is equal to what? There's something we have to do first. Because surface area is always what? Squared, yes? And our lengths are what? To the first, aren't they? They're just a length measure. Well, I need them to be proportional, because if we're talking about square units with surface area, I need our other lengths to be squared also. Because when we talk about areas, our scale factor has to be squared. Surface area, our scale factor needs to be squared. And now, yes, we can multiply both sides by 156. So really tell us that the surface area, the one we want, is 7.5 over 6 squared times 156. Do we agree with this here? And that's it. Now, some of the ones we did yesterday, we simplified that fraction. We plugged in 7.5 divided by 6 squared and saw what we got for that there, and then multiplied it. But we can actually type the whole thing in, because we don't have to do it in parts. We can do the whole thing. Any questions on this here? All right, we're going to look at two more. We'll look at one more pyramid and then look at a cone. So we want to find the surface area of pyramid B. We're going to call it X because we don't know what it is. Now the surface area for the other one is 1620. Surface area over surface area is equal to anything else we need to do? The 16 over 24 needs to be squared so that we have them in the same type unit, squared and squared. Now to get X by itself, we'd multiply both sides by 1620. Because these would cancel, giving us X by itself, which is equal to 16 over 24 squared times. And at this point here, we can type this into the calculator and we would get our answer. Any questions over any of this here? You feel comfortable with this here? All right. We'll look at one cone, and this will be the last one for today, because as we start noticing most of these here, once we get the idea, it doesn't really change all that much. And it works the exact same for this here. So we'd have our surface area over 85 pi is equal to, and the 2.5 over 5 would be squared. Any questions on how we set this up? Are we good with this here so far? Then what would we do next? Multiply both sides by 85 pi. And it would be inches squared. And that's it. Any questions on any of this here? Any questions over anything we did today? All right. And that is it.